Okay, we're on Math 7, Unit 6, Lesson 4 today. This is about reasoning about equations and tape diagrams, Part 1. And it says, let's see how tape diagrams can help us answer questions about unknown amounts in stories. So first we had a little bit of an opener here with the algebra talk, seeing some structure here, and it wants us to find a solution to each equation without really writing anything down. So what we want to look at is looking at an equation like x plus 1 equals 5, and just ask yourself, well, what number plus 1 is going to get you to 5? And so hopefully just using some mental math, some logic there, you recognize that, well, 4 is going to work well there because of 4 plus 1 equals 5. I know it says don't write anything down, but since this is a video, I just want to make sure you're following along there. The same is true over here for number 2. Except the difference here is that we're trying to get to 10 as our final answer, and so we're going to multiply 2 by whatever is inside of here. So when I find the sum here of x plus 1, whatever that number is, when I multiply it by 2, I want to get to 10. Well, I know mentally that 2 times 5 equals 10, right? That's a true statement. And so when I look for a 5, how do I get this little parenthesis section to be equal to 5? Again, that becomes a 4 plus 1, so the number that's missing is 4. So I'm just writing down what I'm thinking in my head so you can kind of hear what I'm going through as I kind of go through the process there, all right? Same is true here. I know I have 3 times something needs to get me to 15, and I know 3 times 5 does that, so once again, a 4 right here would work great to go 4 plus 1 is 5, times 3 is 15. And something similar here as well. I know that 100 times 5 would get me to 500, so I want another 4 right there again. So all of the numbers that are missing here are simply 4. Alright, let's look at section 2. Section 2 is called Situations and Diagrams, and it wants us to draw a tape diagram to represent each situation. For some of the situations, you need to decide what to represent with a variable. Alright, so let's look at the first one. It says that Diego has 7 packs of markers. So we know we have 7 packs of markers, and that each pack has X markers in it. After Lynn gives him 9 more, so I'm going to just write the word more here since I can't circle it, 9 more, he has a total of 30 markers. So what we know is that if I was to create a tape diagram of this, something like this for now, I know that in total there are going to be 30 markers. So I could put that up here on top just to begin with if I chose to. That's my total, 30 markers. We also know that he has 7 packs of markers, right? 7 packs of markers, and each of those has X markers in it. So I could create 7 little boxes, 1, 2, 3, 4, 5, 6, and 7. All right, and that has X markers are in each of those boxes. So 1, 2, 3, 4, 5, 6, 7. I don't know how many of those there are, but I know that there are 7 of the boxes with X markers in it. After Lynn gives him 9 more markers, so we have 9 more additional ones there, that's what I left that space there for, then he has a total of 30 markers. So that's what we have there when we look at number 1. We're going to break that up to have 7 packs of markers there, plus the additional 9 that Lynn gives him. So we end up with something along the lines of 7x plus a 9 for that total of 30. We'll come back to that at a later point here, but let's move on to the next one. The next one shows that Elena is cutting a 30-foot piece of ribbon, right? So we have a 30-foot piece of ribbon that she's going to be cutting, so we're chopping that up for a craft project. She cuts off 7 feet and then cuts the remaining piece into 9 equal lengths of x feet long. All right, so what do we know so far? We know we have 9 sections here, and we know that we also have a 7 section here, right? So 9 sections of x right there, and we have 1 section of 7, and our total is up here at 30. So to make this work, I know that I'm going to have 9 sections of x, which will look like 1, 2, 3, 4, 5, 6, 7, 8, 9 sections of x. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1 section of 7. In total, what we have though is we have 30, a 30-foot piece of ribbon. So this is my 30-foot piece of ribbon. we take off 7 to begin with, and then we take whatever's left and put it into 9 equal lengths of x, right? So the idea here is that she starts off with 30 for the whole ribbon. But what's happening is that if I was to find the sum of this, I'd have 7 plus 9x can get to you that 30 right there. That's kind of the idea. There's my 9x here, there's 9 of those, and 7. We also could look at it this way. This is the same as saying she has 30. She's going to subtract 7 feet, and then after she does that, she's going to have 9 segments with of a length of x. So it's another way of writing that same equation. All we're doing is we're moving the 7 from this side to that side to make it 30 minus 7, because that's how the story kind of reads right there. Let's look at number 3. For number 3, it says that a construction manager weighs a bundle of 9 identical bricks and a 7-pound concrete block. So we have 9 bricks, and then we have 1 7-pound block. The bundle weighs 30 pounds. So the whole thing weighs 30 pounds again. But in this 30-pound thing, we have 1 7-pound block. That's our 7-pounder right there. And then once again, what do we have? We have 9 identical bricks, which we don't know how much they weigh, but there are 9 of them. So once again, we're going to do this. We're going to do 1, 2, 3, 4, 5, 6, 7, 8, and 9. Finish that out. Put my x's in there. 2, 3, 4, 5, 6, 7, 8, 9. So those are my 9 identical bricks, whatever those weigh. That x represents how much they weigh, but I don't know what that is. We know we have 1 of the 7-pound bricks, and in total, it's going to weigh 30 pounds. So we'll break this up like that and write 30 on top for our tape diagram. And look something along those lines. For number 4, a skating rink charges a group rate of $9 plus a fee, so $9 plus a fee to rent each pair of skates. Rate of $9 plus a fee. Yeah, a family rents 7 pairs of skates and pays a total of $30. So we know we have $9. Okay, that's our rate, and then there's a fee for the rentals of the skates. And this family is going to be renting 7 pairs of skates. So what happens is when they get to the skating place, there's a group rate of $9. They're going to pay that right away. That's welcome to the skating rink. It's going to cost you $9 to be here. Then they're going to rent their skates. All right. Oops, going a little backwards here, I think. So we have a skating rink charges a group rate of $9 plus a fee to rent each pair of skates. So the family's going to rent 7 pairs of skates. 7 pairs of skates, which we don't know what that's going to be. Yeah, we're okay. So sorry, we know that the 7 pairs of skates are our x value. So we're going to do 1, 2, 3, 4, 5, 6, and 7. And these are our skates here. We don't know how much those are, but we know that there are 7 pairs of skates, and the total for all this is going to be equal to $30 again. So this becomes an equation like 9 plus 7x equals 30, and again we could solve for x if we chose to. And then finally, number 5, it says Andre bakes 9 pans of brownies, and he donates 7 pans, so we have 9 pans of brownies. He donates 7 pans to the school bake sale and keeps the rest to divide equally among 30 students. And this is an interesting problem, but let's look at it. First of all, 30 students, I've been doing 9s and 7s and breaking that up. This is going to be really a pain to do, isn't it? Right? I mean, I don't really want to make 30 of these things. I really don't want to. So let's say here, to start off with, we know that there are, in this case, there are 9 pans of brownies, is what he starts with. That's awesome. He's going to donate 7 pans to the school bake sale. So we could say, well, this is what 7 pans is going to look like, because that's going to be most of it is 7 pans. Right? That's our 7 pans here. And what's left of it, which we know 9 minus 2, we know that right in that space are going to be 2 pans left in that space. he's going to take those 2 pans and divide this section equally among 30 students. Now I could draw this as 30 small lines like this and put 30 little tiny bits in there, right? And that's not 30, I'm just making that up. Or I could just write down this is going to be 30s. That's kind of a shortcut, which is what I'm going to do right now, because that would take forever. And this is why a tape diagram eventually loses its usability, right? To make one with 30 squares is just silly, but I could do that there. So in this case here, we know 7 pans plus 30 times s is going to equal 9. Now this is a little different here, and what's strange about this problem to me is that you're separating 2 pans into 30 slices, or 30 sections. So you're taking 2 pans of brownies, pan of brownie, and you're dividing those 2 pans into 30 equal parts, right? So you're going to break that up until you get to 30 equal parts, you know, whatever that's going to look like, okay? Now, the next thing it wanted us to do here is it did say, right, for some of the situations, you need to decide what to represent with a variable. So we did that already. We said that we talked about what our variable represents, so we're okay right there. Now, when we get to 4.3, this next section, we have now, it says that each situation in the previous activity is represented by one of the equations. So we have 3 equations right there. Match each situation to an equation, and then find the solution. So we're going to match, find a solution, and then we're going to just talk about what it says for each one of the situations there. So when we go back, we can look at, well, where did we see a 7x plus 9 equals 30? And there are a couple places here. We see that in number 1, and we also see it in number 4. So we see this in number 1 and number 4 is where we see that one at. For this 9x plus 7 equals 30, I see that in, we can make this an x for now. I see that in number 3, and I see that in number 2, right? So number 2, it made it there, 9x plus 7 equals 30, and 9x plus 7 equals 30. So that shows up in number 2 and number 3. And this 30x plus 7, which is here, equals 9, shows up in number 5. So that's where those equations are going to be. So let's now find a solution to match each of these equations. And what we'll do is we'll take a look at numbers 3, 4, and 5, because that will be one of each. So we go back up to number 3, starting there. And to find a solution, we can rewrite this as 7 plus 9x equals 30. And to find a solution, we'll subtract 7 from both sides to leave us with 9x equals 30 minus 7 is 23. We'll then divide both sides by 9, and x is going to equal 23 over 9. Now 23 over 9, I might want to rewrite that as a mixed number. 9 goes into 23 2 times, right? 9 times 2 is 18. And what's left? So I do 23 minus 18 gives me 5. So my remaining fraction is 5/9. So what this tells me in this problem here, if I look at the brick problem, is that my value of x is 2 and 5/9. So these identical bricks right here, the bundle of 9 identical bricks, each one weighs 2 and 5/9 pounds. That's what the x is telling me there. So each of these is 2 and 5/9 pounds, and when I add them up and add the 7 to it, I end up with 30. For number 4, when I solve this one, I have 9 plus 7x equals 30. I'm going to subtract 9, so that 7x equals 21. Divide both sides by 7, so that x equals 3. So what does this 3 stand for there? Well, it said there was a fee to rent the skates, and they rented 7 of them. So what is this $3? That is the rental fee for the skates. That's what that's going to represent right there. And then finally on number 5, we have 7 plus 30x equals 9. And so we'll subtract 7, 30x equals 2, divide by 30 on both sides, so that x equals 1 over 15. So if I had those itsy bitsy little squares there, what that would tell me is that each person gets 1/15 of the 2 pans that are left. I have 2 pans left of brownies, and each person gets 1/15 of those 2 pans that are left to be able to enjoy on their own. How much is that? I have no idea, but it's 1/15. Okay, so that's just matching the situation, finding the solution there, and talking through about what the solutions tell us about each situation. So in summary, it says many situations can be represented by equations. Writing an equation to represent a situation can help us express how quantities in the situation are related to each other. And that's really the key takeaway here. We write an equation to help us show how the quantities are related to each other. And they can help us reason about unknown quantities whose values we want to know. And that was the idea with today's activity there. Let's take a moment now and go through your homework. All right, as I'm sitting here in this new room I'm doing the work in, I realize I forgot my ruler. That's okay. It says draw a square with a side length of 7 centimeters. Well, 7 centimeters is about a pinky. Okay, so I'm going to go 7 centimeters is something about here. Maybe a little more than that. 7 centimeters, that's 1, 2, 3, 4, 5, 6, 7. Something like that or so. So if I was to draw a square with it's about 7 centimeters, you should have something that looks about like that for 7 centimeters for the length. Now in terms of the perimeter, it wants us to predict the perimeter and then predict the length of the diagonal of the square. The diagonal is going to be this length right there. Notice here when I see this square, again it's not perfect, I didn't draw mine, you should do yours with a ruler, sorry about that today. This diagonal seems a little bit longer than what's there. Almost imagine that if I took my my pencil, right, and I said, okay, well there's the end of my pencil here, it comes out to where it says clear point right there. If I swing that out wide, notice that my clear point, it extends beyond the length, right? So it extends beyond there. So it's going to be a little longer than whatever the 7 is. So my prediction here, because if I swing that out, it comes out to about here, something like that. I would say that the perimeter is going to be 7 and 4 times. My perimeter should be about 28 centimeters, and the diagonal should be maybe about 10 centimeters there. It looks like it's about 3 more little chunks to get out that wide. If you actually measure yours, what you're going to find is that your perimeter is indeed 28 centimeters, and the diagonal for your square, I believe, comes out to be 9.9 centimeters. So my estimation was pretty close, and hopefully you did yours right, and you can show your teacher a nice square there. So are they close? Mine was pretty close, and hopefully yours are too. Number 2, it says to find the products. So we're going to be doing some multiplication here. So first of all, let's take a look at, besides the numbering, because you can do that on your own, notice this is a positive times a negative, so that's going to give me a negative answer. Here I have a negative times a negative, that's going to give me a positive answer. Negative times a positive gives you a negative answer. Negative times a negative gives you a positive answer. Now, when you do the math, 100 times 0.09, right? 100 times 0.09 becomes, I have 009, and then this becomes a whole bunch of zeros there, so I didn't move the decimal point over for 2, so I start here, move it over 2 spaces, so I end up with just simply -9. For the next one, I end up with -7. I'm going to multiply that by 1.1. I'm not going to worry about the negative sign right now because I know it's going to be positive, so I'll do 1.1 times 7. 7 times 1 is 7, 7 times 1 is 7. I have 1 behind the decimal point there, so I'm going to move that over, make it 7.7, and that is a positive 7.7. Next, we have 7.3 times 5. So 5 times 3 is 15, 7 times 5 is 35, plus 1 is 36. I have one digit behind the decimal, so I'm going to hop over here one spot for a negative 36.5. And then finally we have 0.2 times 0.3. 0.2 times 0.3 is 0.6, or 6 at least there, 3 times 6, but I have 2 behind the decimal, so I got to move here and move one more over to put a decimal there, which means I need a 0 to hold my place. So I end up with 0.06, and that's positive for number 2D. All right, number 3. Here are 3 stories, and there are 3 stories here for you to read. All right, we have one about a family buying tickets to a show. We have a story about juice, and we have a story about someone working at the art fair. And here are the 3 equations. 3x plus 6 equals 27, 6x plus 3 equals 27, and 27x plus 3 equals 6. So let's break this up into 3 sections. We have the family story, we have the juice story, and we have the art fair, the art story. Those are our 3 stories. So I want to put each equation with one of these. Let's look at this one. So the family buys 6 tickets to a show. They also pay a $3 parking fee, and they spend $27 to see the show. So we know that our sum total is going to be $27. These 2 choices seem to be pretty good in terms of the 27 part, but let's see the other part. I have a $3 parking fee. It's not going to be parking multiple times. I'm going to park one time, and then I'm going to buy 6 tickets. So for the family going to the show, the one that makes the most sense here is going to be 6x plus 3 equals 27. The next one says, and the x is going to represent, in this case here, what's x represent? X represents the number of tickets. Okay, so x stands for the number of tickets. Actually, it's going to be the cost for ticket. So we can say ticket price there. That's fine. Because we know it's 6 tickets. So ticket price. The next one we have Diego has 27 ounces of juice. He pours equal amounts for each of his 3 friends and has 6 ounces left for himself. Okay, so he's going to take the 27 ounces there, and what he's going to do is he's going to divide. He's going to take it and pour it into 3 things. Everybody, there's 3 friends. 3 friends take the juice and they get to separate that out, right? So it's 27, it's like being divided by 3. Now I don't have a 27 divided by 3 anywhere, so I get a little stuck there. Right? I've already used this one, so we're done with that one. But I look here, 27 times 3, but we're not getting more, so that's not going to work out too well. So when I look here, this one here is like 3 friends get some amount of juice, and then there's 6 ounces left over for a total 27. It reads almost backwards here, but that's the idea, is that there are 3 friends who get some juice, and then there are 6 ounces left for himself, and that's why he started off with 27. I could probably write that the other way to make it 27 equals the other thing. So the x in this case here is going to stand for the juice, the amount of juice each friend gets. The juice for friends. And that leaves us then with the last equation. Let's see if it works here. Jada works for 6 hours preparing for the art fair. She spends 3 hours on a sculpture and then paints 27 picture frames. So we have 27x plus 3 equals 6. So those are the 6 hours preparing. Here's the 3 hours for sculpture and then painting 27 picture frames. Because this is hours, what this x is standing for here, x stands for the time she spent on the frames. Alright, so we don't know what that is, but it's going to be the time she spent on the frames there. For part B, what it wants us to do is find the solution to each equation. So we've done part A, which is the first part, the equation, and what x stands for. Now we need to solve it. So let's look at this. We have 6x plus 3 equals 27. I subtract 3 for 24, so 6x equals 24. When I divide 24 by 6, I end up with x equals 4. So what does that tell me? In this case here, it says the ticket price was going to be $4. For the juice, we do 36 plus 6 equals 27. I subtract 6 from both sides and I put 21. So 3x equals 21. I'll divide both sides by 3, and x equals 7. What's that tell me? It tells me each of his friends got 7 ounces of juice when he's divided the juice up to start with. And then this last one, 27x plus 3 equals 6. We subtract 3 from both sides. 27x equals 3. We divide by 27. And so 3 over 27 can be reduced, and x equals 1/9. So what does that mean? That means it takes about 1/9 of an hour to paint a frame. That's how long it takes to do that there. Let's see if we got all the parts here, right? Yep, we have the solution to each equation, got that done there. And we talked about what each one of those variables represents. So you can write that on your paper and explain it to your teacher, and you're good to go. Let's look at number 4. Number 4. It says, here's a diagram and its corresponding equation. Find the solution to the equation and explain your reasoning. So what do we see? We see it has a whole amount, the tape diagram of 21. We can see we have 6 sections that have x, and we have 11 there. So we know that there's 6 of the same amount, and when I add that to this 11, I have in total 21. So we don't know what this story is saying, but here's what we have. Let's find a solution. To find a solution, we subtract 11 from both sides. So I end up with 6x equals 10. Divide both sides by 6, so that x equals 10 over 6, which can be reduced to 5/3. And I could either leave it like that, or I could write it as 1 2/3. So the value of each of these x's is going to be 1 2/3. And so when I add those all up, plus the 11, I should get a total of 21. And that does work out just fine, right? So these are all 5/3 there. And finally, number 5, we're going to plot these points, and then we're going to see the vertical distance between D and A, as well as, I believe, the distance between B and C. Yep. All right, so let's plot them out here. A is at 3, 2, and so I'll get my marker out here. So we have 3, 2, that's where A is at, and then we have 7.5, so about here, and 2 for B, and I have 7.5 and negative 2.5, so that's going to be here for C, and D is at 3, negative 2, right there. So what's the vertical difference between D and A? So we're looking at the difference between 2 points, between D and A. And so what I can do is I can say, well, I know I have A is at 2, and the difference means subtract. And I can subtract that from this point here, which is at negative 2, right? And so 2 minus a negative 2 is going to be equal to 4. So is that difference between here and here 4? Well, we can take a look. 1, 2, 3, 4. That is the distance, or the difference between D and A is 4. When I look at the difference between B and C, it's similar. B is here at 2, and then I'm subtracting from it from this one here is at negative 2.5, right? So in this case here, the difference is going to be 4.5 is the difference between those twos there. Alright, so that's what I did in that case here. You may want to put the absolute value in there, because when you're talking about a distance, the distance between 2 points is going to end up being positive. So that's why I would put that there perhaps. But again, check your teacher and see what they want you to do. That's it for today, and we'll see you next time.